Welcome to ClickMyProject.com. Our project title is a secure optimum distributed detection scheme in under attack wireless sensor networks. Abstract. We address the problem of centralized detection of a binary event in the presence of beta fraction falsification sensor nodes that is controlled by an attacker, spatially uncorrelated distributed wireless sensor networks. The falsification sensor node sends the 1-bit test statistical over orthogonal channel to the fusion center, which linear combines them to reach to a final decision. Adopting the modified detection coefficient as an alternative function to be optimized, we first derive in a closed form of FC optimal weights combining. But as these optimal weights inquire a priori knowledge that cannot be attained in practice, this optimal weight linear FC rule is not implementable. We also derive in a closed form the expression for the attacker flipping probability and the minimum fraction of compromised agents that makes the FC incapable of detecting. Next, based on these insights gained from these expressions, we propose a novel and non-complex relativity based statistic to identify the compromised agents and then adopt the weights combining proportional to their assigned reliability matrix. In this way, the FC identifies the compromised agents and decreases their weights in order to reduce their contributions towards its final decision. Finally, simulation results illustrate that the proposed strategy significantly outperforms the existing compromised agents identification and mitigation scheme. Let us see the flow of our project. First, in wireless sensor network, we have to deploy our network. Our network contains 1000 cross 1000 meter range, and wireless sensor network is used for many applications such as tracking the system or sensing the range. In our project, first we have to implement our energy implementation, that is, we have to allocate energy for all nodes. The node which have the highest energy is taken as a neighbor sensor nodes, and the information is sent through this neighbor sensor nodes. So first we have to identify our source node, then we have to follow our first one step optimal solution, that is weight calculation is implemented by using MDC implementation. So we have to calculate the coefficient weights for all the nodes. The node which have the highest correlation difference between the source node means we have to take that node as an attacker node, and that attacker nodes are identified, and the information is transferred via the node which are all not in attacker range. So the information sent via that sensor nodes, which is truthful sensor nodes. Then we have to calculate the performance using the matrices throughput, energy, delay, and the parameters of packet delivery ratio. Let us see the output of our project. For running our project, we have opened the VMware workstation. So in that, click that terminal window. So in that terminal window, we have to change directory to our project code. For that, cd space our project folder and our code folder. Then we have to run this command prompt using ns space main.tcl. So these things denotes the weight calculation and MDC implementation for our secure distributed system. So this is our output window, which is called the NAM window. NAM is nothing but the network animator, which is used for animating our TCL file. So this is our speed so we have to put it in 10 milliseconds, and when we click on this play forward button it will be works. So this blue color denotes all the nodes are in now blue in color, which is the energy efficiency. That green color denotes the energy efficiency, so all the nodes have that particular energy models. After that 3 seconds, the source and the destination nodes will be formed. So first network is deployed. The region is 1000 cross 600 region. For 1000 means x direction in 1000 and y direction in 600. So now the node 0 is formed as source and the destination node is formed as 4. Now the transaction is done. So the source node, which is 0, is sent the information to that neighbor node 1. This transaction is done by using our TCP connection. Transmission control protocol is used for obtaining these TCP connections. After that, one is sends the information to the neighbor node. Now the node 1 sent the information, that is data packets, to the neighbor node, which is 2, and these dotted lines denotes the TCP packet, and it's sent, and the number of packets sent information is denoted here. Now the falsification node is identified. Now node 5 is act as a falsification node which drops the packets. These dotted lines denote the CBR packets, that is drop the packet 16.6. At the time of 16.6 it will drop the packet 230 bytes. In 1050 bytes it will drop 230 bytes, means remaining packets will be sent to that destination. So we have to identify that falsification node using MDC implementation. After that the information is transferred via the source node, that is neighbor node, to destination node via this intermediate node, which is not the falsification node. So this weight denotes the node which have the node which does not have the falsification node is hence have this weight, which is denoted in green in color. So all the nodes are having weight 1. The falsification node doesn't have any weight, so we have to identify that falsification node and send all the information via the truth node, which is in weight 1. So this is for our output NAMP file. When running our graph, there is performance evaluation. Simply go to terminal window and type GNU plot space delay graph. So delay dot plot. So this is our delay graph between our existing system and the proposed system. Existing system compared to the proposed system, it will take more than delay compared with our proposed MDC implementation. Thank you for watching.